Okay, let's start today's session. It's 1 minute past 4. Uh, Good afternoon to all of you. So, we're going to go through topics number 16 and 17, which are frankly very easy. Um, let's open the lecture slides and concentrate on them. Okay, Module 16 is about network security fundamentals. Whenever you plan a network as a network engineer, you have to understand the concept of network security. Cisco has got a dedicated security stream as well. But in CCNA 1, we touch upon network security a little bit in Module 16 so that you're aware of network security. It's a very important aspect in networking, especially in these days, because uh, we are living at a time where the network is really vulnerable. Okay, so it's very important for us to understand the concept of network security. So we'll be going through security threats and vulnerabilities, network attacks, how to mitigate. Mitigate means how to decrease these network attacks. And we will also go through some device security. Okay. Security threats and vulnerabilities. Let's have a look at these. Okay. Now, uh, as I told you, a network is not a perfect solution. It has got many vulnerabilities. It has got uh, many loopholes through which people can take advantage of it. Okay, certain terms you should understand. The person, the individual who tries to access your network, okay, the sort of a person who tries to access your network is called a threat actor. Okay. Now, a threat actor can be a one person or it can be a group of people, and their desire is to get information or to sabotage your network. Now, a threat actor can get information from you, steal information from you, can get can make sure that you go through data loss and manipulate you, can steal your identity, and can also disrupt your service. These are some of the things that a threat actor does. Now you have to make sure that you make your uh, network as much foolproof as you can. So we'll be looking at some of the concepts we study over here. Okay. When we talk about vulnerability, we have got three main kinds of vulnerability. Okay. Technological vulnerability, configuration vulnerabilities, and security policy vulnerabilities. Okay. So besides that, a network resource can also be physically compromised. Okay. The most important thing is making sure that your equipment is physically secure, especially your intermediary equipment. When I say intermediary equipment, I'm talking about your switches and your routers. Because if a person attacks that, it can do the maximum damage. Okay. Now, physical security. The first thing is hardware threats. When you say hardware threats, the question that you have to answer is, where should we keep the equipment? Okay, which place is the most secure place that you keep the equipment? Now, when you go to an enterprise, when you go to a institution, do they actually show you where they keep their uh, 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 routers or where they keep their switch? They don't do that. It's under lock and key, and it's always secure. So you have to keep it in a building which is the most secure, okay, so that nobody can attack it. We also have environmental threats, okay. You have to make sure that wherever you keep your equipment, it should be at a constant optimum temperature, okay. Let's say you keep it in Malaysia. If it's Malaysia, you keep it at a temperature of 10 degrees centigrade, okay. So this will make sure that the machines, okay, all your routers and switches work at optimum temperature. Now, let's say you go to a cold country like Canada, okay? In winter, in order to make sure that we don't have extreme cold, again, we have air conditioning. Again, we can maintain a temperature of 10, okay? Here we have air conditioning so that we avoid extreme heat. In a country like Canada, they have air conditioning, so they avoid extreme cold. Okay. Uh, we also have electrical threats. Okay. You have to make sure that you have got a backup power. Otherwise, if power is due to some accident or due to some intentional attack, power goes off, it can affect the working of your company. Okay, so you should have a backup power, generators or uninterrupted power supplies, and so on. You should also have a maintenance uh, threats. Sometimes what happens is the network engineer is relaxed. The network engineer does not enforce the strict policies. So the network engineer, which is most probably if you become a network engineer, you should ensure that you adhere to strict enforcement of policy by all the people working under you. Okay, all your staff and technician. If they do not follow the policy and the instructions, if they do not do proper cabling and they do not label, then perhaps it is time for them to leave the institution. In other words, you have to ask them, do your job properly or leave. Because I have this policy that I have to enforce. Because at the end of the day, my dear students, if something goes wrong with your network, only the network engineer is answerable, not the technician. Okay. Now let's look at some of the network attacks that we have and how we can protect ourselves from them. We have got the most basic one, which is a virus. Now, virus always attaches itself to a file and copies itself and attaches itself to other files. Besides a virus, we also have a worm. Okay, a worm is a virus, but there is a very important difference. Okay, they are standalone software programs. They don't need to attach to a application. Okay? And they can make copy of themselves. Now we have got another special kind of virus known as a Trojan horse, which is a normal application which appears to be helpful. You know, all these applications that you download from the internet, some of them may well be Trojan horses. You never know. That's why you have to be very careful when you download applications from the internet, when you open attachments on your email, you have to be very careful, okay, because they might appear to be a user-friendly program, but behind they would be doing some background processes that will be harmful for your computer. Okay. Now, there may be even some apps running on your computer, okay, that are Trojan horses, but they don't reveal their main intention. So that's why you have to always go and do a proper research before you download a app. So remember, most of our malware, malicious code is either viruses, worms, or Trojan horses. Now, when we talk about attacks, we have got, when we talk about network attacks, we have reconnaissance attacks, access attacks, and DOS attacks, denial of service attacks. Uh, Reconnaissance attacks, normally what happens when we try to find out what systems a company has, okay, what services they have, and what is the loopholes or vulnerabilities that we can take advantage of, okay. For example, by using commands like nslookup and whois, okay. Have you tried the nslookup command on your own computer? It's very powerful. It tells about which server you're connected to. Like last week, we discussed about this. So using these reconnaissance attacks, you can get more information about the different enterprises. We also have access attacks. Access attacks is either you want to know a password of a person. You can try brute force or a program that does brute force. Brute force means trying all the combination or guessing a password of a person. Okay. In fact, there is a program that tries all the combinations and finds out a password of a person. Okay. We also have trust exploitation, where a malicious person, a threat actor, the keyword threat actor, uses unauthorized privileges to gain access to your system and taking whatever they want. We also have port redirection. Okay, using port redirection, a person, for example, can use SSH, even a secure socket, okay, a secure SH, and connect to a compromised host A. And since host B is trusting host A, what happens? Through host A, it can also attack host B. We also have man in the middle. A threat actor is between two legitimate persons in the company, and it can change the data or modify it, thus wreaking havoc. Okay, these are some of the actual experiences in the actual uh, uh, business world that we have seen. Okay, so these are some of the things that we have to guard our institutions from as a network engineer. Now, the DOS attacks are very, very serious attacks, and it can bring down your network. It can bring down your website. Okay, denial of service attack, where you have got multiple requests for a service, so much so that the host, the server, gets overwhelmed and it cannot keep up with the requests. Okay, this is a major risk, and they interrupt a lot of business for an enterprise. Just imagine when you are shopping at Lazada or or Shopee. If somebody does a DOS attack and knocks down their server for, let's say, 1 hour, now just imagine in that 1 hour how much money they could have earned. But because the server was knocked off because of DOS, what happened? These people were financially ruined. Okay, even that 1 hour, or even AirAsia or any other enterprise that is on the network, if you do a DOS attack, you can bring them to their knees. We also have a powerful DOS attack known as DDoS, a distributed DOS. Now, this one is very powerful in the scenario that what we do is we create a sort of botnet. A botnet is a program consisting of multiple zombies. Zombies, as in a network of infected hosts. Okay, so these botnets, what they do, from different network locations, you see distributed DOS, from different network locations at the same time, they do a DOS attack and bring down the service. Okay, so how are you going to protect yourself from all this? So how do you mitigate these attacks? How do you decrease these attacks? Okay, you have to first of all know what are your solutions. Okay, most organizations employ a defense in depth approach, also known as layered approach to security. They follow a layered approach to security. That means, hey, at the top I have my external router. From there it goes to my aggregate switch. From that it goes to the other switch, and so on. Depends on what kind of institution or enterprise and how big. Okay, now most common security devices that we have a virtual private network. Okay, for example, if I'm traveling anywhere, I can still access my network at curtain because I'm accessing a VPN. We also have a firewall. What does a firewall do? It ensures that people snooping in from outside, everything is checked. Okay. We have an ASA firewall, an adaptive security appliance firewall, which is a combination of a VPN. It's a combination of other packet sniffer, packet fence, sorry, is a software, checking your packets and making sure that everything coming in is properly uh, vetoed and checked. Okay. We also have an IPS system, an intrusion prevention system. I forgot to tell you, sorry. And a firewall can be software based. It can also be hardware based. Okay. When you do CCNA security, you will be working with an actual firewall equipment. We also have an ESA and WSA. ESA is an email security appliance to make sure that your emails, attachments connected to the emails are not worms or viruses or Trojan horses. We also have WSA, the same thing, but for web security. Uh, when you are using a server, most of the servers, either Linux or Windows, because these are the two main servers in the industry, both of these servers have to follow AAA security, which is first authenticate only. With authentication, you can get in. And once you get in, you cannot access everything. You can only access what you are authorized to access. And finally, even if you are authorized to access, you need to audit, do accounting of what the person is doing. Okay? Don't think that audit is done by default. No, you have to create that audit to check. Okay? What is this person doing in there on their computer? Okay? Even if they have proper authentication and authorization, you still need to check the details. Okay? Yeah. It's important for you to keep backups also of your enterprise. Data backups are usually stored offsite to protect the backup media. In early days, we used to have tape backup and we used to have hard disk backup on site in the company itself. Okay, there will be a network engineer who, at the end of the day, will do a tape backup. A tape which looks like an actual uh, small tape. Okay, I don't know whether you have seen what a tape looks like. Um, have you seen a VHS tape? Something like that, but much more smaller. Okay, so we will do a tape backup. But now we don't do that anymore because with the advent of uh, faster network and the cloud network, we subcontract this to third-party application providers, storage providers. So whenever we use a software, at the end of the day, the backup is done automatically. So the third-party company takes care of the backups. We don't have to worry about it. Okay. So how often you do the backup, frequency, where do you store, what is the security of the backups, how you validate the backups, all these things also the network engineer should decide. Okay. Because if you have a backup, my dear student, just imagine you have got backup of the fees that you pay, or backup of enterprises pay information. From the backup, you can actually get the information. So make sure that it's secured in a proper location. This is very serious. If God forbid, the company that does your backup loses some information and it is in the hands of a threat actor, in the hands of a wrong person, then you can even sue the company. Okay. Now, on your end device, if you're using Linux or if you're using Windows, uh, usually uh, they update and make sure that whatever new attack comes to our network, our internet, they create a patch for it. So what you have to do is always make sure that your Windows is updated to the latest update. Okay, because if you look at these antivirus companies, they are always on the lookout. Software companies, operating system companies, they are always lookout for a new threat, a new attack. Okay, every day there are thousands of attack. People who in their pajamas in their garage just sit down and code and create a worm and send it out in the internet. Okay, so they are always on the lookout, looking for zero-day apps, zero-day worms. Zero-day as in uh, there is no solution for those worms or viruses. So they immediately create a solution and they update the operating system and then they put the patch so everybody updates this. For example, in Windows 10, they have said that they are not going to update the operating system. They will just, they will not create a new version of the Windows 10. They will keep updating Windows 10. Okay. So you have to make sure that you always update your end devices, your hosts. Besides that, as we discussed, the AAA has to be enforced by the network engineer. Authentication, authorization, and accounting. When you log in into your network as a student, you cannot access anything that belongs to the staff. If I access the staff domain, I cannot access anything that belongs to HR. If HR accesses its domain, it cannot access anything that belongs to IT. You see where I'm going from this? There is always different levels of domains and different authorizations. Okay, and at the end of the day, always do an audit about who is accessing what, so-called accounting. Now, network firewalls, first of all, they keep outside traffic from coming in and doing malicious tasks, malicious packets. If you have got a DMZ server, a DMZ as in a demilitarized zone server, what does a DMZ server do? It is a server that people access from outside. For example, your Moodle. Your Moodle is on a DMZ at Curtin, which you access from outside. It is also available to be updated from inside, as long as you give a proper authorization. Okay, so the firewall will ensure that only valid packets are let in, okay, and not malicious packets. Now, I'm not saying that it is a perfect solution. No, that's where research comes in. That's where you can do a research on pre-existing firewalls and say, hey, we still have a problem here. I have found security loopholes and we can patch this by doing this or that and so on. So research security is also big, is very big these days, where you can write papers or do your final year project based on uh, security. These are the three kinds of firewalls you have: packet filtering, application filtering, URL filtering, and stateful packet inspection. Okay. Now, the last one, stateful packet inspection, it will check and make sure that, hey, is this, because it can recognize and filter out what kind of attack, especially a DOS attack. Most of our firewalls can have all the four aspects inside one firewall. Remember, firewall can be software-based or hardware-based. At the endpoint, you have the host, the device user. Okay. Now, endpoint security was very easy a few years ago, but ever since the advent of smartphone, endpoint security has become much more challenging. Okay, because just imagine a student who can log into their university's network and then keeps loses the phone. If a malicious person wants to attack, they can use that phone, go to the network, download whatever they want, leave a malicious code, because they have got access to that student's device. Okay, so that's why it's very important for employees to be trained on proper use of their network and their devices. How do we have device security? Some ideas. Okay, so when we look at operating systems and when we look at our network intermediary devices, like when you want to go and buy network devices, let's say I travel to Singapore, I buy my Cisco routers and Cisco switches, and I bring it to my company. Now, by default, uh, they have their own security, which is inadequate. Okay, now you have to set the security to make sure, as a network engineer, that the network will be secure. The Cisco Auto Secure feature can be used to assist securing a system. Now, some things you have to remember. Default username and passwords should be changed immediately for all the equipment. Access to system resources should be restricted to only the system administrator, to the network engineer or some other technicians who know what they are doing. Whatever services that you are not using in the router or the switch, turn it off. Okay, because usually when you buy equipment, the equipment has been resting uh, at a warehouse for a long time before somebody purchases it. Okay, so this these purchases that you make doesn't mean that your operating system, network operating system, the iOS is up to date. Okay, so you have to keep on patching it up to make sure that it's up to date. These are some suggestions to you, like use a password length of at least 8 characters, preferably 10 or more characters. You can set these things in your router or in your switch. I will even share with you the commands. You can say, hey, this password for this should be at least 10 characters. Or if the person attempts to log into this router 3 times in 60 seconds and all the 3 times the password is wrong, make sure that the person doesn't access the router for 5 minutes. You can set all these things. I'll be sharing with you some of the commands. Okay. So some of the ideas they're giving you over here is how to make sure passwords more secure. I won't go into details and read them all. Uh, Now, some ways you can make sure that your password is secure on your router and switch. We are talking about our intermediary devices. First is encrypt your password like this. Service password encryption. Okay. You have to be in configuration mode to do this. Here you can say security password minimum length should be 8. Okay. If you really hate the people in your in your your technicians, you can increase it to any number that you want. Okay. uh, you can also say, hey, login block for 120 seconds. If within 3 attempts within if 3 attempts within 60 minutes is unsuccessful, then block for 120 seconds. Some of you have experienced this in the lab. You have to wait for perhaps 1 minute or 2 minutes or 5 minutes until you can attempt again to log in. And remember, I told you in the lab, we always give the password either Cisco or class. And that's the reason I keep telling you all don't give passwords, so that the next batch of students who come and use the equipment, they don't have any problem. Okay. You can also use the line VTY0 for command, which will allow you to give a password if you're accessing your router or your switch through a network by using telnet or SSH. Okay. What does it mean over here? Line VTY04, that means 5 users, 0, 1, 2, 3, 4. Maximum 5 users can access your router at the same time, not more than that. Okay. Password Cisco exec timeout. That means when you are accessing through a network and you are not you haven't touched the router for, let's say, by default 10 minutes, then the connection is broken. But you can bring it down to whatever time. For example, I'm saying that if this is not being used for 5 minutes and 30 seconds, time out the connection. Okay. Even if the person is connected to the router, it will cut the connection, and then the person has to connect again by using the password. You can also say, hey, I don't want the person to use telnet because telnet may not be secure. Only SSH, transport input, SSH, and so on. Okay. You can also show the running config, pipe symbol, select a section line VTY. It will tell you all the details. Okay. So as a network engineer, you have to memorize all these commands. It should be in your mind so that when you troubleshoot, okay, you can remember all these commands. Okay. It's not easy being a network engineer. Okay. It's a well-paid job, but it's always you'll be perhaps at least in the early years, very tense and very worried. Yes, the ports that you don't use, the services that you don't use on your routers and on your switches, disable them. Okay, easy. That brings us to the end of our chapter 16. Now let's continue with chapter 17, building a small network. Now, all of you can proudly say that you know how to create a network because you have worked with a router, you have worked with a switch. Those of you who have done lab number 10 are already network engineers. I can proudly tell you all. If you have done lab number 10 and lab number 11 successfully, the IP version 4 addressing system, if you have done these two successfully, your CCNA 1 is ready to go. That means no problem. Okay. So in your spare time, just go again through lab number 10 and lab number 11. Now, keeping that in mind, as a network engineer, you have to plan. Okay. When you create a network, you have to plan. A small network, for example, consisting of a network in a building. An example, Curtin network is not a small network. That is a huge enterprise university network. Okay. So we'll be looking at some of the devices in the small network, network application and protocols, scale to larger networks. How does a small network allow it to be scaled up as the company progresses and becomes bigger? Verify connectivity, some of the iOS commands, troubleshooting methodologies, and scenarios. Okay. So devices in a small network. The majority of businesses start small. No matter which business, if you are starting a business from from 1999 to 2020, any business, if you want to thrive, if you want to survive, you have to have network connection. Okay. So designing a small network is obviously very simple. Okay. But planning will help you to make sure that it's secure and scalable for the future. Some of the factors you have to see is how much is your budget, uh, speed and types of ports and interfaces. What about scalability, expandability, operating system features and services? Okay. So when implementing a network, you have to create an IP addressing scheme. Okay, you have to see which one is going to serve you. And you have to create an IP addressing scheme which will work for you. As a network engineer, what network engineers usually do, they do the simulation first. They use packet tracer first. Okay? Once they use a packet tracer, they can even show it to their technician. They say, hey, look over here. It works on packet tracer. Why, when you went and did the same setting on the switch, it didn't work? What did you do? Then the technician can go back and check. And even if the technician cannot solve the problem, then the network engineer will go and check and solve the problem. Okay? So you have this packet tracer simulation, which is not only used by students, it is also used by seasoned network engineers, okay, before actually implementing a solution. Another keyword they use over here, not just plan, document. Okay, this is very important, and this is something which usually network engineers won't do. Okay, document means if they are leaving the organization, they leave a document to pass to the next network engineer. Okay, so that the new network engineer uh, can easily familiarize himself or herself with the network. Now, First thing you have to remember when you design your network, always have redundancy. Redundant servers, redundant connection, redundant switches, redundant routers. Why? Because one fails, the other can take over. Okay? You know, sometimes when you're in an institution, suddenly your network goes off. Okay? In those institutions, when suddenly your network goes off, you know that, hey, there's no redundancy over here. If one goes off, that means perhaps the switch has blown off its microprocessor or fried its electronics or whatever. So they have to go and quickly replace that. And it's not just replacing, you have to again sit down as a network engineer and configure it like the last one, correct? So redundancy helps. If this connection doesn't work, it will go through another switch connection. So redundancy is your friend as a network engineer. Keep that in mind. Okay. Another thing is you have to plan for your traffic, okay, your traffic management. The highest priority should be your voice, then your email, then perhaps instant messaging, and then your uploading and downloading of files. Now let's look at some of the applications and protocols of a small network. Okay. The reason they're concentrating on a small network is, hey, because you are new network engineers just finishing CCNA 1. Okay. So first, design a small network, plan a small network, document a small network, and from there, you can move up to more challenging scenarios. So, applications in your network will be of two types: network applications or standalone applications. Okay. Now, network applications will be using, they are being programmed to use the network. So how they work and what they do when they work, you have to keep that in mind during your implementation. Now, some of the protocols which you are going to be using in your network is definitely Telnet and SSH. Why SSH rather than Telnet? Because it's secure. There is end-to-end encryption. You use HTTP or HTTPS. Why HTTPS? Because it is secure. We got SMTP, we got POP3. But rather than using POP3, we use IMAP because it's a better option. Every time it updates your email immediately. Okay. If you're transferring file, uploading or downloading rather than FTP, use SFTP. Okay. Besides that, give automatic IP address. Okay. There is no time for a network engineer or even for a technician to go from host to give IP address. That would be crazy. So you should have a DHCP configured on your router. Okay. This is something you will learn when you do CCNA 2. How do I configure my router to be a DHCP server? Give it a pool of address and then say whichever computer connects in this network, it has to get an IP address from this router. Okay, so you should have a DHCP equipment. Why do I use the word equipment? Because traditionally we make our router a DHCP server, but sometimes you may make your PC a DHCP server as well. Okay. What about domain name service? When you access your Moodle, you don't type an IP address, you give a DNS name. Okay, so that has to be resolved by a DNS server. And keep in mind that these may not be 3 or 4 different servers. Sometimes you buy a very powerful computer which runs in tens or 20,000 ringgit, and all the equipment, sorry, all the servers can be hosted on just one server, on just one computer. Okay, you can do that. Depends on the traffic, if it can handle the traffic. Besides that, you know that businesses uh, they have got an infrastructure. When you build any building these days, uh, the 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 planning is done in such a way that they keep in mind where does the uh, UTP cable run from, which room you're going to keep the network equipment, as in switches and the routers and so on. It's already put in the planning because they cannot think about building a building or an infrastructure without network equipment. Uh, IP telephony uses dedicated servers, but these days we have got a voice over IP system, which is even at Curtin, you must have seen the telephones are all IP telephones. Okay, and we also have to keep in mind what are the real-time applications that we are going to run in our enterprise, so that if I want to stand up and walk to my colleague's office, rather than doing that, I can perhaps just do a video call, a real-time transport protocol, and real-time transport control protocol. Using that, I can do a just a video call and you know solve the solve those problems. What if your small network is going to become a large network? And this is very much possible. Because when you have an organization, organizations grow. Okay? As I said, you have to do documentation, physical and logical topology, what it looks like. Look at all the labs you do on packet tracer and on real equipment. The first page, what they show you is a topology, right? If there is no topology, it will be very difficult for us to imagine what the network looks like. Similarly, when a new person joins an organization, let's say as a technician, so the network engineer is going to take him inside a room and open a chart and say, hey, this is our topology. And topology of an organization is not shared outside. Okay? They don't show it to anyone. Just like that. Only a person with access, okay, and managerial position can see the topology. Have an inventory of what are the devices that you have, what are the backup devices that you have. Even at Curtin, we have got staff who come to our office and do an inventory of the equipment that we have. Okay, the budget, and analyze your traffic. Okay, analyze your traffic and check which time is the peak performance, which time is the least peak performance. Why you need to do these analysis? For example, if there is an issue in the network and it has to be immediately solved, rather than do it on a Monday where everybody is using the network, and if you stop the network, it's going to affect the whole workflow of the institution. You put it on a perhaps a Saturday or a Sunday. Yes, that's why I told you network engineer, well paid job, but very difficult to get peace and quiet and family time. Now, but don't get me wrong, it's a very satisfying job. If you love being a network engineer, the challenges itself, when once you solve the challenges. Remember, those of you who studied programming under me, I kept telling you, when you solve a problem, a program, you get this, I use the word progasm, the satisfaction that you have solved a problem. It's the same thing with network engineering. I've seen many students in the lab as well. They solve a difficult situation, network situation, that topology that's given to them, the lab that's given to them, and they are so satisfied and happy. Okay. So you have to determine your traffic flow in your small network, okay, and gather information. You have to use protocol analyzers to make sure that everything is uh, all your system is working perfectly. Okay, in other words, you have to know your network as a network engineer. Okay, and the more experience you get in this line, the better the pay. Okay, now as an employee, your network utilization, uh, there will be a lot of built-in tools by the operating system to know how your network is performing. What kind of operating system you're using, what is the CPU utilization, RAM utilization, which drives they use, okay, which non-network applications are used, which network applications are used. Some network administrators know even the host and device, which applications you're running, from what time to what time. Okay, why is this important, you may ask? What if an employee decides to run a let's say a service that banks on Bitcoin or generates money through mining? They're not supposed to do that on an organization's processing power rather than on their own personal processing power. So that makes it important to do uh, for a network engineer to check everyone's work. Okay? But here, what they're talking about is uh, end user utilization. Why end user utilization is important? Because a network engineer has to know what kind of operating system and how this operating system works on the applications that are run in that enterprise. Okay, just imagine in your network you have got a very slow system. What happens? You will always judge the network engineer in your mind. It's a newbie. He doesn't know what he's doing, right? Now, verifying connectivity. Okay, this thing you have done multiple times in your lab. How do you verify connectivity? By using an ICMP message known as ping. Okay, now ping, uh, there are different ways you can use the ping command. Okay, on a Windows 10, uh, when you do a ping, you expect 4 consecutive ICMP echo replies. Okay, now besides that, a ping can also be used in extended mode. For example, in your router, you can type ping, and then let's say it will ask you for target IP address and which source you're coming from. And then based on that, your target and the source, you can do a detailed ping. Uh, besides ping, besides ping, you can also do a trace route. We looked at trace route last week. Let's look at it again. Trace route, or in Windows, we use tracert. The problem with ping is, hey, if you want to know whether you can connect to an end device, ping will always be helpful from one device to another device. Yes. But ping does not tell you which equipment is having a problem. Let's say you want to find out from one end device to another end device. If it doesn't ping, why it doesn't ping? Where is the problem? Then you have to use traceroute or tracer. Look, over here, I'm trying to find my access from PC A to PC B. Let's say I ping and I have a problem in my ping. The ICMP reply does not come back. So in those situations, I use a tracer. Okay, remember tracer? What does tracer do? We studied it last week, my dear student. It tells you how many hops you have to go. Start with 1, 2, 3, 4. 4 hops to reach PCB. So I tracer to PCB. So once I do a tracer, it says, okay, the first hop is okay. The first hop is okay. But the second one, there's no connection. You get the star symbol, the asterisk symbol. Okay, request times out. So what does this mean? Immediately you understand, hey, there is something wrong between these two routers, R1 and R2. You get me, my dear students? You could not isolate this problem by using ping, but tracer will allow you to isolate it. Okay? In future, when you are doing a troubleshooting exam, for example, if you are doing a competition, a network competition, let's say there will be a network competition with a cash prize. A situation like this will be given to you. So how do you isolate the problem? By using tracer. Now, another situation you can use a tracer. For example, this is a successful. You have got 3 hops. Okay, it says that there is no issue with the network. Everything is successful. Over here, another situation, you're doing a tracing. You see there is a problem with the second hop and the third hop. Can you see that? So you know that the connection between these two is faulty. Okay. We also have extended tracer command. Just like an extended ping command, we have an extended traceroute command. Okay, where again you can give your target IP address and the source IP address, and it will give you the details. The details of your tracer is all over here. As a network engineer, once your main work will be network engineering, you will learn all the basis and details of a command. Okay. If you don't know the details of a command, just use the question mark operator and it will give you the details. Okay. What about host and iOS commands? Okay, now this is something again you have used as a host. If you want to know your IP address, you use ipconfig. If you want to know the details of your IP address, that means you want to know your MAC address, you want to know all the details like that, then you use ipconfig/all, space/all. If you want to know, if you want your DHCP address to be released and you want a new DHCP address, then you use ipconfig release or ipconfig renew. Sometimes, I don't know whether you have experienced this, those of you who use Unify or even Streamix, suddenly your network stops working. So what you do is you connect to the telecom helpline, and the technician at the other end tells you, try ipconfig release or ipconfig renew. Okay, or try both and then see whether your network is working. Okay, because it gets a new DHCP address from the DHCP server, which can be a router or a computer. Okay. Or even if your DNS doesn't work, the ipconfig display DNS command displays all of the cached DNS entries on your Windows computer system. Cache means it's already existing on your computer system. Just try it out later. Okay, ipconfig / display DNS. On a Linux system, ipconfig won't work. We have to use ifconfig. Okay. You can also use IP address command to display addresses and their properties on a Linux system. Okay. You have to be familiar with both the systems, Windows, Linux, as well as, unfortunately, a Mac system as well. Okay. Mac operating system is mainly based on Unix, just like Linux. So they also use ifconfig. Okay. And you have got their own Mac OS commands to verify host IP settings, which include network setup, list all network services, and network setup -get info. Okay, for those of us who are using a Mac system as an end device. Besides that, you can also use the ARP command. Okay, remember, ARP stands for Address Resolution Protocol. That information is stored inside the router, which has the information of the logical IP address to the MAC address. Okay. The ARP/A command displays the known IP address and the MAC address binding. Okay. What is the IP address and the actual MAC address? To ensure that the ARP cache is populated, ping a device so that it will have an entry in the ARP table. Okay. The cache can be cleared by using this command. Now, these are some of our show commands. Show running configuration, or this is something which we use very commonly. If you remember, I taught you this. Show IP interfaces. The show commands, okay, it will show you all your IP interfaces. Okay, these are the commands and their description. Besides that, we also have a special command called the CDP command, which is actually standing for Cisco Discovery Protocol, which shows you, for example, show CDP neighbors. It shows you all your devices which are connected to your system. Okay, it has got, again, it has got different command substructures which you can follow as shown over here. This is the command that we have used a lot. Show IP interface brief. Okay, you can also just type ship int br. Okay, so it shows you on your router what is the interface, what is the IP address, whether it is up or down. Remember, whenever you call me to tell me that you have got some problem with your switch or with your router, the command that I type is this. Okay, because this gives a key insight. Some of the commands you have to know, like this is one of those commands, show IP interface brief. Okay. Troubleshooting methodologies actually tells you what are the steps that you have to take to solve certain scenarios. Step 1, identify a problem, establish a theory of probable causes, test the theory, establish a plan of action, verify solution, document findings, and so on. So if you follow these steps, it is commendable, but it's not a must. It's rather a should. Okay. So that's it for these two topics that we have gone through. Next week, during our lab lecture, I'm planning to actually do actual network, small network solution on packet tracer so that you can follow and implement it in your actual lab. Okay, implement it in your actual uh, implement it in your actual uh, skill-based lab exam. Okay, because the more practice you have, the better you get at this. So that brings us to the end of the session, my dear students. Lab number 16 and lab number 17, there are few labs which I'm going to release to all of you. These labs are guided labs, my dear students. So just follow them so that you gain more knowledge. You don't have to submit it to me. Okay? Just go through the guided lab, which tells you more about security, what are the commands you can type, and how you can create a small network. Okay. Within a few weeks, within 2 weeks, you are going to do your uh, final exam. The final exam is going to be, I'm talking about Cisco. Your Cisco final exam um, is going to be uh, done individually. Remember last time I told you that it's going to be uh, uh, invigilated, but unfortunately we cannot do that. So your final exam is going to be like your chapter exams, which you all do without referring to any online content. I know you all are very honest. Okay, so your final exam also is going to be like that. You can be as honest as the chapter exams. There is one last chapter that you have to do. I will release that perhaps this week or next week. I'll look into our course and see which is the best thing to do. Um, and your skill-based exam as well is going to be open book. I cannot enforce invigilation on your skill-based exam as well. I can just create a scenario and I will email to you. Sorry, not email. I will put it on Moodle and I'll give you 1 day, one whole day to solve the problem. In the lab, if you do a skill-based, you've got 3 hours. But I will give you 1 day to solve that skill-based scenario on packet tracer. And when you are done, uh, what you do is you can put your student ID and name on that packet tracer file and immediately upload it to Moodle. Okay? And then I check it and mark you. So that is a few weeks away. Right now, we have come to the end of CCNA 1. This session, I'm going to record it and upload it to Moodle, just like the previous sessions. Okay. Anyone has any questions? Please follow the lecture sessions on Blackboard as well, okay, by Dr. King Sun. Please follow those lecture sessions. Unfortunately, we couldn't have a lecture, but those lecture sessions, the instructions are we just follow those lecture sessions. If you have any questions or are stuck anywhere, please come back to me. Okay. Thank you very much for your attention. Before we leave, let me just count how many students we are here. Yeah, about 25 students. Thank you very much for your attention. Uh, please practice if you have time on Packet Tracer. And if you have any questions, you can always ask me later. Thank you very much. I close the session now. Okay? Take care.
Thank you, sir.
Thank you. Thank you, my dear. Take care.